Hello guys, welcome to Physics Science Double Award, and today we're going to be doing equations of motion. Now we're going to start with the first equation here. The first equation is acceleration equals to final velocity minus initial velocity divided by time taken. And the second equation is distance is equals to half brackets initial plus final velocity multiplied by time. And now the third equation is going to be initial velocity multiplied by time plus half a t squared, a for acceleration and t for time taken. Now the fourth equation is going to be v squared equals to u squared plus 2as. Now for your a is going to be acceleration, of course, and s is going to be the distance. Now you have to keep this equation in mind so that in the long run we're going to do short exercises, example based on these equations. Now you have to remember them, you have to have them at the back of your hand. Now the first example, a cyclist traveling at 80 meters per second slowly decreases speed until he comes to rest in 16 seconds. Calculate his acceleration. Now the first thing that we do, we list everything that we're given in this equation. Now the first thing that we have, that we notice that we have, is the initial speed. And the other thing that we have, they say he comes to rest, which means the final velocity is going to be 0. And the time taken, he comes to rest in 16 seconds. So we have t, the time, which is 16 seconds. Now the equation that we are going to apply based on what we have here is going to be the first equation of motion. It's going to be a equals to v minus u over time taken. Now we're going to substitute everything that we have in the equation in order to find the acceleration. Now let me just put it here. Acceleration is going to be equals 80 minus 0 divided by 16. Now I try by all means to leave the units outside when I'm doing my calculation. It's much neat and clear without equations, but you have to remember there's those units. It's much clear without those units, but you have to remember them. Now 80 minus 0 divided by 16, we have 5. Now our acceleration is going to be a equals to 5 meters per second squared. Now the second example, a car traveling at 50 meters per second increases speed at the rate of 2 meters per second squared in 5 seconds. Calculate its final velocity. Now the first thing that we do, we list each and everything that we have in this equation. Now the first thing that we have is the initial speed, 50 meters per second. Then we have the acceleration, 2 meters per second squared. Then we have time, which is 5 seconds. We are looking for final velocity. Now we are going to use the first equation of motion, which is acceleration equals to final speed minus initial speed divided by time. You make final speed is the subject of the formula, v subject of the formula, which is going to be v equals to u plus a t. Now we substitute everything here that we have. 50 plus 2 multiplied by 5. Bring in our calculator. And that's going to be 50 plus 2 times 5. You get 60. Now which means your final velocity is 60 meters per second. Now the third example, a cyclist started from rest and reached a speed of 80 meters per second in 10 seconds. How far did he travel? Now we are looking for the distance, the final distance. Now the first thing that we do, we write everything down that we have in this equation. So now the first thing that we have here is that the cyclist started from rest, and every time that something starts from rest, which means the initial velocity is 0. Now which means initial velocity equals to 0 meter per second square, and the final speed that was reached, final velocity, is 80 meter per second, and the time that was taken is 10 seconds, and we are looking for the distance to travel. Now for this equation, we're going to use the second equation of motion, which is distance equals to half brackets u plus v multiplied by time taken. Now we substitute everything that we have here in this equation, which means the distance is going to be equal to, initial is going to be 0 plus final multiplied by time taken. Now we bring in our calculator. Remember 0.5 multiplied by 80 and multiplied by 10. Then we have 400 meters. Now that's the final distance that was traveled by the cyclist. Now the fourth example. Now a motorist traveling at 20 meters per second accelerate uniformly at the rate of 5 meters per second squared in 10 seconds. How far did he travel during the first 10 seconds? Now the first thing that we do, we list everything that we have. Now the first thing that we have is the initial velocity, 20 meters per second. Then we have the acceleration, 5 meters per second squared. Then we have time taken, which is 10 seconds, and we are looking for the distance. Now for this, we are going to use the third equation of motion, which is distance equals to initial multiplied by time plus half acceleration t squared, which is time. Now we're going to substitute everything that we have into this equation. Now to multiply by 10 plus half brackets 5 multiplied by 10 squared. Let's bring our calculator. Here is going to be plus, this is going to be half multiplied by 5 times 10 squared, 150, which means the final distance is going to be 450 meters. Now the final example that we're going to do, a body started from rest and accelerated uniformly at 5 meters per second squared until it covered 200 meters. Calculate the final velocity. Now the first thing that we do as usual, we list everything that we have in this equation. Now the first thing that we have here is from rest means now the initial velocity is 0. Then we have the acceleration, 5 meters per second. Then we have the distance traveled, 200 meters. Calculate the final velocity. Now for this one, we are going to use the fourth equation of motion, which is equals to v squared equals to u squared plus 2as. Now let's substitute everything that we have. We have 0 plus 2 times 5 times 200. Let's bring our calculator. 2 times 5 times 200. We have 2000. Remember, this is not your final answer because we still have the v squared and we are looking for v, which means you put everything under the square root. Now when you do that, your final answer is going to be 44.72 meter per second. Now that's your final velocity. Thank you.